Ramanujan for G is now available on the Google Play Store. Try it out for free.
Good morning, class. So today we are going to start the new unit, the class 11th. Okay, so which is permutations and the combination. So in the previous lecture we have completed till the probability, right? So today we'll start with the permutation and combination, that's P and C. Okay. So here in this unit, first we'll move to the fundamental principles of countings. Okay, so let me first put the headings for your unit. Permutation and combinations. Okay, so first we will know the fundamental principle of counting. Okay, so suppose we will write multiplication principle. Okay, suppose if an operations can be performed in m different ways, following which a second operation can be performed in n different ways, so then the two operations succession can be performed in m into n ways. This can be extended to any finite number of operations. That means m number of different operation. N is also number of different operation ways. Here also you can add ways. Okay, so two operations can be performed as m into n ways. M into n ways. Okay, so we can have copy, then we'll look at few examples, okay, for this definition. Okay, make a note of this first. Okay, so now we'll look at examples. So first, a person wants to go from station P to station R via station Q. So there are four routes from P to Q and five routes from Q to R. So how many ways can he travel from P to R? Okay, So he can go P to Q in four different ways. P to Q in four different ways. Okay. And Q to R in five ways. Q to R in five ways. So number of ways of travel from P to R is 4 into 5, that is 20. And this is your answer. So now I hope you understood the previous definition. Okay. So make a note of this. Okay. Next example. Suppose a college offers 6 courses in morning, 6 courses in morning and 4 in the evening. So the possible number of choices with student if he study the course wants to study the course in the morning and one in the evening is okay. So let's solve this problem. The way the student has 6 choices in the morning, out of which he can select one course in 6 ways. For the evening, he has 4 choices, out of which he can select one in 4 ways. So total number of ways will be 6 into 4, that is 24. Easy. Now the next thing is addition principle. So if an operations that can be performed in m different ways and another operation which is independent of the first operation can be performed in n different ways. So then either of the two operations can be performed in m plus n ways. This can be extended to any infinite number of mutually exclusive operations. Okay, so let's look at one example. So you will get to know this definition, like a person wants to live, wants to live, station Q, and there are four routes. There are four routes from station Q to P, and five routes from Q to R. In how many ways? In how many ways he can travel to Q? Okay, so this is not the multiplication. Here, few things are different. First, he can go from Q to P in four ways. Then Q to R in five ways. So Q will become 4 plus 5, that is 9 ways, because both are independent operations, right? So you can copy down this. Okay. Next, if we talk about the previous problem, a college offers 6 courses in the morning and 4 in the evening. The number of ways students can select exactly one course, either in the morning or the evening. So it means the student has 6 choices from the morning, out of which he can select only one course in 6 ways. For the evening course, he has 4 choices, out of which he can select one in 4 ways. So total number of ways will become 6 plus 4, that is 10. Okay. So now let's start with the factorials. Okay. So if n is a natural number, then the product of all natural number goes up to the n fact n is called the factorial n, and it's denoted by n factorial or n. So now that is n of n minus 1, n minus 2 goes up to 3 to 1. So it's obvious to note that n factorial is n into n minus 1 factorial, that is again n of n minus 1, n minus 2, then again n of n minus 1, n minus 2, n minus 3, etc. So we can say 0 factorial is equals to 1, 1 factorial is equals to 1, 2 factorial is equals to 2, 3 factorial is equals to 6, 4 factorial is equals to 24, 5 is 120, 6 factorial is 720. Okay, so you can make a note of this. Right, so now start the word. Now we'll start with the word permutation. Permutation. We're starting with the word permutation. Okay, so just a minute, wait. Okay, yeah, so we'll start with the word permutation. So in this, each of the different arrangements which can be made by taking some or all of a number is of the things is called a permutation. Let me write the definition. Each of the different each of the different arrangements which can be made by taking some or all of a number of things is called a permutation. Is called a permutation, right? Now counting formulas for permutations. Okay, counting formulas. So first is without repetition. Without repetition. So the number of permutations of n different things is denoted by NPR. Okay, so that is NPR will become n factorial by n minus r factorial. Here it should be in this range. Okay, and the number of arrangement of n different things is number of arrangements of n different objects taken all at a time is npn, that is n factorial. Okay, suppose we look at one example. The number of ways in which 4 person can sit on 6 chairs. So that is 6 chair for 4 people. So 64. That is 4 into 5 into 3. So that becomes 360. Okay. So you can first make a note of this. I can copy this example. Okay. Next is with repetition. With repetition. So here, the first, the number of permutations of n things taken all at a time, and p are alike of one kind, and q are alike of second kind, and r are alike of third kind. Then set will become n minus p plus q plus r of all different things. So it becomes like, we can write first n alike objects, n alike objects, and r and q are also alike objects. R and q are also objects. Similarly, r are also alike objects. Okay, so here total it will become n factorial by p factorial, q factorial, and r factorial, right? Similarly, the second one, the number of permutations of n different things taken r at a time, when each may be repeated by any number of times, is n to the power r. So let me write the number of permutations of n different things taken r at a time, when each thing may be repeated of times, is n to the power r. Okay, so suppose we are going to take one question. The number of words that can be formed that can be formed using word, that can be formed from word. Committee, COMMITTEE is. Okay, so solving, there are n letters in the given word which has two t's, m is also 2, e is also 2. Okay, so hence it will become 9 factorial, that is total number of words 9 divided by 2 factorial, 2 factorial, 2 factorial, that is 9 factorial by 2 to the power factorial. Okay, so with this we are going to wind up the lecture here. Next class we'll see a few more examples related to the permutation. Okay, so thank you guys, see you in the next lecture.